Hi everyone, good evening. How are you? Ashwin, Hari, and Srinidhi. You three are here. Hari? Okay. Yeah, hi Bhaskar, I want host access. Yeah. Am I audible to you guys? I'll share my screen, okay? Let me know if you guys are able to see. Am I audible to you?
Yes, sir.
Okay. See, yesterday I left at the deck of card, right? So what I'm gonna do, I'll just try to explain you the 52 deck of card. Try to get it in one go so that, in probability also you'll be facing the same problems. Probability will be there in your this 11th standard as well as in 12th standard. Okay. Probability is the most important chapter in mathematics. Okay. Playing okay, so fifth deck of cards. Okay, so we all know there are 52 cards in total. Okay, so there are 52 cards, and of course, if there are 52 cards, so 52 cards will be different, all different cards. Okay, so we have in 52 cards are made of 4 suits. Okay, 4 suits. So first suit is your spade. Spade is of black. Spade is black in color. Okay. Let me write like that. 52 cards are divided in 2 colors, black and red. Okay. Black and red color. Okay. So that means black and red both have 26 cards, 26 black cards and 26 red cards. All right. Now this whole deck is made of 4 suits, and out of which 2 suits are red and 2 suits are black. So the black suits are, one is your spade, okay, and another is club. The red suits are your diamond, and heart. Okay, you have anybody have seen these 4 cards, means the deck of 52 cards. So spade looks something like this. Yeah, it's not a bad thing, by the way. Those, you should know this for mathematics. So spade looks something like that, and the club is something like this, right? If I'm not wrong, something like this, like a tree, you can say, or a small flower,
Yes, sir.
something like that. So these two are black in color. Okay. And we have in red, we have diamond, right? So diamond is simply this. This will be a diamond. So diamond is red and one is your heart. So heart is normal heart shape, what, something like that, whatever it is. And of course, if you want, we can write the equation for all those, but with that's not the thing here that we do. Now, since these are 4 different suits, these are called suits. Okay, so we have 4 suits: spade, club, diamond, heart. Now in all suits, so that means how many spades will be there? How many spades? See, 52 cards, out of which 26 are black, 26 are red. So how many spade is there in 52 cards?
13, sir.
13, right? 26 by 2. So 13 of this, 13 of club, 13 of diamond, and 13 of heart. All right. I don't have a heart. How to make a proper heart here? Is it okay?
Okay, sir.
Yeah, fine. You can understand. Fine. Okay. So these are the now in all this, now these 13 cards, these are made of one king. So just understand what this is made of. One king. Okay, which is in card it is written as K. Okay, one of queen. Okay, represented by Q. One of jack, J, represented by J. One, and these are followed by numbers. So numbers are from 10. So 1, 10, obviously 10, 9, 8 up to 2. And the last card is one of ace. It is called ace. A-C-E, ace. Okay. So there are total of 13 cards. So the value of ace is 1. And then the value keeps on increasing. 10, the value of 11, jack is 11, 12, and 13. Okay, so there are in total of 13, these 13 cards are present in all suit. Okay, in all suit, there is a king, there is a queen, there is a jack, number 10, 9, 8, 7, 6, 5, 4, 3, 2, and an ace. Okay, is that clear?
Yes, sir.
Okay, now tell me how many aces are there in total?
4, sir.
Yes, of course, one ace will be of spade, one ace is of club, one ace is of diamond, one ace is of heart. Okay, so total, see, whatever I'm writing for individual card, it is valid for all. Okay, so total 4 aces, right? Out of which 2 ace will be red, right? And 2 ace will be black, isn't it?
Sir.
Similarly, it goes for all other cards. Like we have written ace, jack, queen, king. Okay. So how many king will be there in total? How many king? Total, how many kings are there? Anyone?
4, sir.
Yeah, of course it is 4, right? Total 4 kings are there. King, or we represent it by, let's write K. Total 4K, not 4K video. That is different, right? Now 4 queen, 4 of jack, right? Out of which 2 are red, 2 are red, and
Black.
2 are black. Okay, all. This is valid for all cards. Now I think this is all the information I think you need for a card deck of card, 52 cards, this similar, right? Then of course, when you play some other games, so see this, all games are just mathematical permutation and combinations. Okay, these are all mathematical theories. Games, any game you can name, any game, like cricket, football, anything, everything includes mathematics, right? So what better way to understand the deck of card? You play any game with these cards, all are based on probability, or there will be a subject, those who want to study computer science maybe, or economics. So game theory, the subject is game theory. Okay, and there is another one more graph theory. Okay. Those even in even if you are studying history, you should study game theory and graph theory. These are really two very awesome subjects that you can study. Okay, it's a part of mathematics. So I suppose you can, if you want, you can study. So I'll just scroll it from top to bottom. Just go through once and let me know if you have, if you have any doubt understanding the deck of cards.
No doubt, sir.
Okay, so I'll just scroll it down and you can see. Oh, okay, so shall we solve problems based on deck of card?
Sir.
Okay. Now, let me find out if there is any problem based on deck of card. Obviously, we are solving combinations. Is there any question in exercise 7.4 based on deck of cards? Yeah, question number 6. Exercise 7.4, question number 6. Solve it. So determine the number of five card combination out of 52 cards if there is exactly one ace in each combination. Okay. What's the meaning of this problem? First, try to understand that. Yes, can anyone solve this problem? Have you ever tried solving this problem? Did you try exercise 7.4? Did you try to solve this exercise? Tell me in yes or no. That's it. That's what I want to know. That's it. Anyone try to solve exercise 7.4? See, don't expect good results if you are not working. Don't put the blame on anyone else. If you are not working, just accept it. Okay. Do question number 6. Just try. In a deck of 52 cards. Okay. Just do it. How many aces are there in 52 cards? In a deck. See, in deck of cards, there are 52 cards, right? How many of these 52 cards are aces? 4 are aces, right? You have to select 5 cards. Right? You have to select 5 cards. Now do it. I think I have given all the information needed. So, you have to make a combination of 5 cards, right? In which you should have exactly one ace, not more, not less. You have to select a total of 5 cards. Total of 5 cards you need to select. Okay. There are total 4 aces, but you need only one ace. Only one ace is exactly, actually not only, exactly. Exactly one ace is required, not more, not less. Okay. So how many combinations are possible? So out of 4 aces, you have to select one ace. So in how many ways you can do that? Out of 4 aces, we need to select one ace, right? So that can be done in 4C1 way, isn't it? Yes?
Yes, sir.
Okay, now how many, see, out of 4 cards, you have selected 1 card. Now you have to select 4 cards. Out of how many cards? See, out of there were how many aces? So total is 52 cards, out of which you have subtracted aces. Okay, so how many is remaining? 48, right? 48, because you have already made selection from these 4 cards. Now you are left out with 48 cards, right? So and still you need to select, total you have to select 5 cards. So out of which 1 you have already selected. So what you can do? So you will select 4 cards, you need 4 more cards, right? So, and you are left out with 48 cards. So that can be done in 48C 4 ways, right? And you need to select all 5 cards, so you will multiply this. So total combination will be 4C1 multiplied by 48C1. Sorry, 48C4. So total you have selected 5 cards, out of which 1 is ace. Got it?
Okay, sir.
Not okay. I don't want okay. Is it okay or you
Yes.
understood it?
Understood, sir.
Yeah. So tell me clearly whether you understood or not. You are able to see my screen, right? Hari?
Sir,
Yes, sir.
Yeah. Anybody else is there in class? Srinidhi, what happened? Shri Kruti, Divya, Shreya. Shreya, you were absent yesterday.
Yes, sir. I had network issues, so I didn't attend half an hour of the class.
Okay. See, we have already with this problem we have finished this chapter. Okay. So now miscellaneous problems are there. We are going to solve some of the miscellaneous problems. If you have doubt, please let me know. Yesterday we had done combinations. So those who were, and please talk in class. Okay. Let's not it be a silent class. It's a very interesting chapter and you guys are not participating. See, binomial theorem, I can understand. It's just, just you have to solve the equations. That's it. But here you have to think more than you solve, right? Okay, let's do a problem based on combination. So let's go for miscellaneous problems. Okay. Okay. Solve question number 21. Wait. Miscellaneous problem. Solve question number 1. Okay. Okay, solve problem number 1. How many words with or without meaning, each of 2 vowels and 3 consonants, can be formed from the letter of the word daughter? Do it. So first tell me whether it is permutation or combination. What do we have to do? Read the question and tell me whether you will solve for permutation or you will solve for combinations. Huh? Is it permutation or combination? See, when exercises are separated, so directly you will just find combination or permutation, right? But just read the problem. You have to understand when you read the problem, whether it is a problem from permutation or the problem from combination. Yeah. Yes. Anyone? Nidhi?
Sir, it's permutation, I guess.
You guess why it is permutation?
Like arranging the letters of that word.
Okay. Okay. Anyone else? Any other guess? Shreya,
Sir, permutation, sir.
permutation. Why permutation?
It has an order, sir.
It has
An order, sir.
order, is it? Read the question again. Anyone else want to try? Nidhi? See, what's the word here? Daughter, right? Isn't it? How many words are there total? How many letters? Sorry, how many letters are there total? How many letters are there?
8, sir.
8 letters are there total, right? Out of which how many vowels have is used here?
3, sir.
3. That means 5 consonants and 3 vowels, right? is in the problem, what is how many words can with or without meaning, right? With 2 vowel and 3 consonants, right? You have to select 2 vowels and 3 consonant, out of which 5 consonant and 3 vowels. Now tell me whether it is permutation or combination. You are not specified to select, like in second position there will be a vowel or a consonant. The order has not been specified. Has the order been specified here?
Combination, sir. No, sir.
No, okay, now understand, you got it is combination, but did you understand why? Why is the question? Shri Kruti, you are able to understand or not? Please tell me, I'll explain again.
Sir, I couldn't differentiate.
Okay, you couldn't differentiate. See, here in the problem, it's been said there are total of 8 letters, fine? Is it okay? Now, out of which there are 5 consonants and 3 vowels, right? That is not a problem. Now, in the problem, it's been asked that you have to use only 2 vowels, okay? And you have to use only 3 consonants, right? That means you have to make a selection here, isn't it? You have to make a selection here, is it or not? Out of 5, you have to select 3. Out of 3, you have to select 2. So there is a selection process going on here. Selection means combination. Okay. Now, why it is not a permutation? Permutation is, order is important in permutation. In combination, order is not important. See, when it's been asked that you have to use 2 vowels and 3 consonants, that means there are 5 positions, right? Yes, there are, you can use only 5 letters, isn't it? So in this, it's been said that you have to use 5 letters, but it has not been specified that vowels will come at this position or consonant will come at any other position. That order has not been defined, right? That means you can put consonant anywhere, you can put vowel anywhere. Understood?
Yes, sir.
Hari, anybody else is having this doubt? Why it is combination and not a permutation? First thing is, here you can see that you have to make selection 3 out of 5 and 3 out of 2. Okay, and the order is not specified, so it's a combination, not a permutation. Now find out. Kruti, are you still able to understand or not?
Yes, sir, I can understand.
See, it will come with practice. Don't worry. That's what I keep repeating to you guys. Keep solving problems. It will be clear. Okay. If you just want to, nothing will come by understanding, just by solving one problem. It is fine to get confused. If you are getting confused, that means you are trying to understand. It's a good thing. Okay. So just try to find out the solution of this problem. So there are 3 vowels. That means how many ways you can select a vowel? How many ways you can select a vowel? There are total of 3 vowels and you have to make selection of 2 vowels. So it can be done using 3C 2 ways. And you have consonants, right? You have how many consonants you have? Total 5 consonants you have, right? Out of 5 consonants, you have to select 3 consonants. And together they will form words. So 3C2 is how much? It is 3. And 5C3 is how much? 10. So total combination of vowel and consonant will be how much? 30. Right? Is it or not? Yes or no?
Yes, sir.
Now see, the problem has still not been solved properly because you see 1, 2, 3, 4, 5. 5 positions are there, right? You have used 3 consonants and 2 vowels. Now what you will do? Now you will arrange these, right? Now you have to use permutation. Why? Now, because since you have already selected, so you have total of 32 combinations of vowel and consonant, right? You have all 32 combination of vowel and consonant. Now that can be arranged among themselves, right? So here, how many, there are total of 5 words. So here, how many words, how many letters can go? Either of the 5 into 4, into 3, into 2, into 1. That means 5 factorial, isn't it? So that means total combination will be how much? 30 into 5 factorial. So different words. These will be total different words. Will be 30 into 5 factorial. That will be how much? 5 factorial is how much? 5 into 4, 20, 60, 120, so 360. 3600. Okay, so these are the total number of different words that can be formed out of these 3 vowels, these 3 vowels and 5 consonants that are present. Okay, got it? So here we are using combination and now we are arranging, so we will use permutation. 5, you understood this, why we are doing the second part, right? Because here we got combination of vowel plus consonants. Okay, now vowel plus consonant, total how many letters are there? 5 letters. Now these 5 letters can again be arranged in 5 factorial ways, right? 5 that will be your different words. That means repetition is not allowed. Once you have used one letter, that means next you cannot use that letter. So 30 multiplied by 5 factorial, that will give you 3600. Understood or not? Let's solve one more problem if you haven't understood it properly. Okay, let's solve question number 3 of that same exercise. So a committee of 7 has to be formed from 9 boys and 4 girls. In how many ways can this be done when the committee consists of exactly 3 girls, at least 3 girls, or the third is at most 3 girls? That means maximum of 3 girls. Let's try this. Anybody is having doubt in previous problem? I suppose everyone has understood this one. Yes or no? Go on, tell me. Solve few more problems. It will get clear. Or anybody is still having doubt? Abhinav, you want to say something? Nidhi, Divya, Shreya, anyone? Naveen, you will not turn on your mic, so no point asking you. Sham?
Sir, can you hear me?
Yeah, now I can hear you. Who is this? Shreya?
Understood, sir.
Okay. Let's solve a few more problems. Okay. Let's solve a few more problems. It will get clarified. Okay. Do question number 3. Just try it. So total 9 boys are there. This type of problem we have solved, but not exactly this problem. So 9 boys and 4 girls. This is problem number 3, right? Yeah. A committee of 7. So a committee of 7 has to be formed. So total 7 places are vacant. 1, 2, 3, 4, 5, 6, 7. Okay. So when you are arranging on this position, that means you are doing permutation. But before this, you need to make selection also, right? How many boys will be there? How many girls will be there? So that is your combination. Isn't it? Yes or no? We have done this in permutation. We have done this in combination. See, we have so far we have studied permutation and combination separately. Now we are studying it combined in a combined manner. So just try this problem. This is exactly similar to the first problem that we solved just now. Anyone got the answer? Anyone want to say anything? You won't be killed, don't worry. See, a committee of 7 need to be formed, right? Of 9 boys and 4 girls. So the first part of the problem is, how many girls are needed in the committee? Huh? How many girls are there?
4.
Shall I end the class? Do you want me to end the class, or you want to speak or something, somebody? Abhinav, are you there in class?
Yes, sir.
So why you are not turning on your mic?
Sir?
I asked something, right? I'm asking something in class. Divya,
Yes, sir.
I asked some question, right? Please tell me how many girls are in first question. I think question number 3A, first part. How many girls will be there in this committee?
Sir, exactly 3 girls.
Exactly 3 girls, right? So girls will be 3. How many total girls are there?
4.
4 girls. That means you have to select 3 girls out of 4 girls. How can you do that?
4C3 combination.
4C3, right? Okay, how many boys will be there now? If the committee is made of 7 persons, 3 of them are girls. So how many boys are there?
4.
4. Total, how many boys are there?
9.
9. So how can you select 4 boys out of 9?
9C4.
9C4. Total combination, how much you got?
Sir, we have to multiply.
Yeah, just multiply this, no? How much you got? How many combinations are possible? Anyone? Anyone? Okay, just write down 4 factorial upon 3 factorial, 1 factorial multiplied by 9 factorial, 4
Sir,
factorial,
9408.
9408. Okay, let me check. So 3 factorial, this will be equal to 4 multiplied by 9 into 8 into 7 into 6 into 5 factorial upon 4 into 3 into 2 into 5 factorial. So this will get cancelled. This we can cancel 2. So 14 into 9 into 4. So 7, 28 into 2, 56 into 9. So this will be equal to 56 into 9. So this will be equal to 504. So these many combinations are possible. Now, what's the difference between this problem and the previous problem that we solved? Why we are not doing permutation here? Okay, so this is the answer, right? 504 combinations are possible.
Yes, sir.
Now tell me why we are not arranging them in 7 different positions, and why we arranged in 7 positions, right? In previous problem, why we did this? Why we filled this 5 positions? First, second, third, fourth, fifth. Anyone please tell me why we did this? We filled these positions, right? 5 positions we filled, but here we are not doing the same. Read the question, you will get it. Read the question. See,
Sir.
in previous, yes.
Sir, if we change the order of letters in the first question, then it will give a new word, sir. But
Yes.
in committee, if we change the order of persons, still it will be the same.
Very good.
So it is a combination.
Exactly. So we just need the combination of here boys and girls. It doesn't matter which position which girl is there, because the team will remain same, right? If there are seven positions, you put girl for, you select girl first or a boy first, it doesn't matter. But if you change the position of letter in a word, the word will be different with or without meaning. That's why we have to use permutation there. That's why you need to fill this 5 places with 5 different words, 5 different letters, right? Understood? Very good, Kruti. Understood or not? Divya? Divya,
Yes, sir.
why we are not using it? Why we are not using permutation?
Sir, because if we change the order also, that is going to remain same in a committee, sir. The persons.
Yes, but why we did it here?
Because if we change the places here, we will get new orders, sir. Yeah.
Or not order. If we change different letter, let's say A you are fixing here, right? Now, if in maybe in second word, if you use A in last place, that will change the word entirely, right? Isn't it?
Yes, sir.
So either you can use DAUGH or you can use TAUGH. These are all different words. Or you can use the same, you just change the position, HUGAD. So this and this is a different letter, although we have used the same letters, right? These and these are different words, although we have used the same letters. But here, if you're selecting girl, 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 boy, 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 right? 4 boys. Or you select girl, boy, girl, boy, girl, boy, boy. The team will remain same team. But here we have different words. That's why we have to arrange it. That's why we are using permutation. Got it or not? Okay, let's do one more problem. Okay, so second part, please someone solve the second part. What is the second part? So at least 3 girls we can use, we have to use. That means it can be more than, it can be 3 girls or 4 girls, right? At least 3 girls. At least 3 girls. How are we going to use at least 3 girls? That means the team has to form of 7. So either there can be 3 girls or it can have 4 girls. So the combinations can be, there are 2 combinations, right? One, it can have 3 girls plus 4 boys, 3 girls plus 4 boys, or 4 girls, 3 boys. Got it? Now, we have already solved the first part, right? So 3 girls and 4 boys, we have already solved. We have got how many ways? 504 ways, right? It can be done. Now 4 girls and 3 boys, how we can do? 4C4 multiplied by, how many boys are there total? Total 9 boys are there, right? 9 boys. So 9C3. How much will be this? How much will be this? Okay, somebody solve it, please. So this will be 4C4 is 1, right? 4C4 is 1 multiplied by 9 into 8 into 7 into 6 factorial. This divided by 3 into 2 into 9 minus 3, that is 6 factorial. So this will cancel. 9, this is 3, this is 4. 12 into 7 is how much? 12 into 7 is 84, right? So 84 possibilities, 84 ways. Now either the team can have 3 boys, 3 girls and 4 boys, or it can have 4 girls and 3 boys. You are getting here we are getting or statement. Here we have and statement. See the difference? That's why we are multiplying here. Here we are multiplying, and here what we are doing, and here we will add. So total ways will be how much? How many? Total ways to form a team will be 504 plus 84. Because either this team is possible, team A, let's say this one is team A or team B. Either this is possible or this is possible. So or statement, clearly or statement is there. So how many ways? 588 ways. Understood? Anybody is having doubt here? Please tell me. See, this is a really nice problem to understand the fundamental principle of counting. Okay. Anyone is having doubt here? Divya, you got it? Shreya?
Yes,
Yes,
sir. I
sir.
got it.
Shreya, you understood? I know you have missed combination, by the way, but combination isn't that tough. We make selections. When we are selecting, we use combinations. That is without orders. I have explained that in the in Monday's class at the end, right? Anybody is having doubt? Shri
No,
Kruti, you
sir.
got it?
Understood.
Okay. Let's solve the third part. Somebody please solve the third part. Nobody is giving answer here. Is it that bad? Is it that tough that you are not able to solve any problem? Because I think I'm kind of explaining most to you guys. I don't explain this much. It's not like I don't want to, it's like I never needed to explain this much. And because I can see that I have to solve all the problems. I'm not even getting a single answer out of you guys. Maybe you have solved it. I'm not saying you haven't, but please tell me so that I can know that whether somebody is able to understand and someone is not able to understand. You have to ask me the doubt. See, again, if we are doing some other chapter, then that time you'll be saying, okay, permutation and combination was tough. But believe me, I think if you can understand, this is the easiest chapter of this book. If you are not able to understand, this will be the toughest chapter of the book, this and probability both. Same thing with this and same thing with probability as well. So what's the third part? At most 3 girls. At most 3 girls. What's the meaning of at most 3 girls? Huh? Maximum of 3 girls, right? Of 3 girls. There are total of how many girls? Total how many girls are there? 4. So a team A can have no girls. Team B can have 1 girl. Team C can have 2 girls. Team D can have 3 girls. But no team can have 4 girls. Right? So if this is the number of girls, so what will be the number of boys? Total, there are 4 girls and 9 boys. The team has to be total of 7. So if there are 0 girls, that means there has to have how many boys? There should be 7 boys, 6 boys, 5 boys, and 4 boys. Okay, so the total, the team can have 7 players. We have already solved for this part D. Now solve for other parts, and so these are the teams. So either this can be the team or this or this. So clearly there is or statement, right? Find out. And somebody please tell me the answer this time. I've practically solved the problem. Just tell me literally the answer. Shri Kruti, Srinidhi. Maybe was the answer. Shreya was the answer. Sham, what happened to Murli? Why is not attending? Okay, my problem. Nidhi, you can type your answer. Hari, Hari Haran, Hari Raghav, both.
Sir,
Abhinav, are you able to understand Abhinav?
Yes,
Are you-
sir. One second. I'm still doing the sum,
Okay,
sir.
good. See, all problems are similar to this, all problems. And do little fast, be a little fast. Yes, tell me, answer. Okay. See, how many ways you can select 0 girls and 7 boys? Abhinav,
Sir, the answer is 1632, sir.
okay, I don't know the answer. Honestly, I don't know the answer. We have to solve it. I'll have to use calculator. So how much you are saying? 10?
No, 1632, sir. 1006.
1632. Okay. This is one number. This is Abhinav. Whose answer is this?
Sir, Abhinav, sir.
Okay. Okay, Abhinav, you tell me. 0 girls and 7 boys. This is team A. Okay, team A. 0 girls, 7 boys. How can we do that?
Sir, 4 factorial by 0 factorial into 4 minus 6 into 4 factorial.
You just tell me in terms of combinations.
Sir,
In terms of combinations, you tell me.
sir, 4C0, sir.
4C0, okay.
Into 9C7.
9C7. Okay, good. How much will be this?
Sir, 36.
Okay, I don't know how much. Okay, now team B. Okay, team B. So in team B, we have 1 girl and 6 boys. Fine.
Yes, sir.
Shreya, how can we select 1 girl and 6 boys? Shreya, 1 girl and 6 boys. Next is Divya. Shreya, are you able to hear me? Can you hear me? Shreya, are you there? Or you left the call? Shreya. Divya, you tell me. See, if you are, why are you quiet? If you haven't understood, ask me. Divya, how many ways we can select 1 girl and 6 boy?
Sir, 4C1 into 9C6.
Into 9C6. Okay. Why we are doing 9C6, Divya?
So there are total of 9 boys, sir. We are selecting 6 out of.
Yes, exactly. Very good. Now team C. These are the possible teams, right? Either it will be team A or it will be team B or it will be team C. Yes, Hari Raghav. So now 2 girls
Sir.
and 5 boys we have to select, right? So how many ways
Yes,
you
sir.
can do it?
4C2 into 9C, sir.
Into 9C5.
5.
Okay. Now last is team D. Fine. Who Hari Haran?
Yes.
Yes, how many ways we can select 3 girls and 4 boys
4C3 into 9C4, sir.
into 9C4? It is clear, right? Why we are multiplying here? Because we have to fill all 7 positions. It's not like if we have we have selected 3 girls, so 4 boys are not required. We have to fill all positions. That's why we are multiplying it here. Okay, this multiplication is because of that. Okay, so whatever value you are getting, whatever value, let's say the value is x, y, z, and let's say alpha, whatever it is. So now we will add these values because either team A is possible or team B is possible, team C or team D is possible, right? All teams simultaneously, all teams will not exist. So final answer will be your x plus y plus z plus alpha. I don't know the values. I think alpha value we already calculated. 4C3 into 9C4. How much is that? 4C3. This one, right? 4C3 into 9C4. So 84 ways. No, sorry, 504 ways. That's what, right? 4C3 into 9C4 is 504 ways. So alpha is 504. Tell me these values, someone. What is that? Did you guys understood this? This one, is it clear or not? Is it clear or not? Huh? Anyone, please tell me, is it clear or not? Why we are doing this? There is completely or statement. Clearly it is or statement, right? That's why we are adding these. Is it? Okay, let's do the next problem. If you haven't understood, please tell me. Divya, is it clear to you?
Yes, sir.
Okay, anybody who it's not clear to them? Shreya? Are you
Sir,
still?
Shreya has network issues, so that's why she couldn't answer.
Okay, so is she able to hear me? Sir, I'm facing network issue.
No,
So-
sir. Because of that, she left the call.
Okay. Kruti, it is clear to you, right? The problems. Naveen, Abhinav,
Yes, sir.
Sham. Shyam, right? Shyam.
Understood. Understood, sir.
Okay, good. All right, let's do problem number again. Is there any problem with using deck of card? Okay, solve question number 8. Miscellaneous. So determine the number of 5 card combination. No. Which problem it is? Is it the same problem? Determine the number of 5 card combination out of 52 cards if each selection 5 cards is the same problem, right? Question number 8 is same as that of we did earlier. Don't do this. Leave it. Okay. Leave it. Let's solve question number 4 permutation on the left. See, question number 4 you already. Question number 11. Solve question number 11. Solve this. In how many ways the letter of the word assassination be arranged so that all the S's are together? Okay. The word is assassination. ASSASSINATION. Okay. So SS, all S must be together. See, when some group of word, some group of letter, or some group of object are together, what do we do? What do we do when some group of words are together? What do we do? We consider all words as all letters as one. So there are 4 S's. S. So there are 4 S in this word or in the combination of this word. So and we have to take all as one. Means all will stick together. Okay, so all will be one letter. We'll consider that as one letter. Okay. First, find out how many ways we can arrange assassination. How many words can we form with or without me? First, write down A appears how many times? A is 3 times, right? S is 4 times. I is 2 times. What else is there? N. N also appears 2 times. What else? All other are only once, right? T is 1 time. Yeah. T and O are 1 time. No? Yes. Now total how many letters are there? 13. But it says all S will stick together, right? Wherever S will go, it will stick together. So we will treat all S as 1 letter, right? So this will become 1 letter. So how many total letters are there now?
10, sir.
So there will be total of 10 letters. Okay. Understood? Now this will be your, how do we do now? What do we do now? So this can be 10 letters can be arranged in how many ways? 10 factorial ways, right? But there are repeated letters as well, right? So for repeated letters, how can we eliminate those similar words? Like, see, if you are writing assassination, you write this A here or this A here. The word will remain same, right? Either you write this A here or this A here. It doesn't matter. The word will remain same. Okay. So because the letters are repeated, so what we will do, we'll divide it. Divided by, so A appears 3 times, so 3 factorial. S already we have combined, so no need to divide it by S. I appears 2 times, right? So I, and N appears 2 times, so divide by 2. Okay, so this is the total possible arrangement of words. So this is the required number of ways. Okay. So do the calculation. I don't know, 10 factorial upon 2 factorial, 3 factorial. So this will be equal to 10 into 9 into how much? Till 6 till 4 divided by 2. Okay. So till 5 you will multiply. 10 into 9 into 8 into 7 into 6 into 5. Because again you have 4. Okay, 4 into 3 into 2, right? 2 factorial divided by 2 factorial, 2 factorial. This will get cancelled. This will be 2. Okay, so you have to multiply these numbers. See, the shortcut method is you can multiply these two. What you will get? 10. And again, 10 into what you can do. See, there is no shortcut. You just need to multiply. I'm sorry, I brought it up. I'm really sorry. So this will be around how much?
Sir, it's 151200. Sir.
How much? 151200.
1200.
Okay. How you did it? You multiplied all the numbers, or you use the
Yes.
calculator?
Yes, sir. Multiply, sir.
Okay, good, good. So you have to be strong in that. I'm really bad in this multiplying these numbers. I'll learn it. Don't worry. I'm sorry. I don't know. I will learn it. Okay. This is not an excuse. So I should not put excuses. I'm sorry. So this is how we can do it. All right. I think you will be able to solve all the problems. If you have understood these concepts. Okay, what we have done till now. So bottom line, we have studied fundamental principle of counting, in which we studied and or statement, okay, of English literature. So whenever there is and statement, we multiply. Whenever there is or statement, we add, right? We studied permutation, that means arrangement, where order matters. And then we studied combinations, where this is called selection, where order do not matter. Order will not matter, doesn't matter. Okay, so order will not matter here because of obviously it's a selection, and it's a one really important formula that we saw is NPR is equal to R factorial times NCR. Okay, we have proved also this formula. We know NPR is equal to N factorial upon N minus R factorial, and NCR is equal to N factorial upon R factorial N minus R factorial. Okay, we have also seen one of the formula that yesterday we have seen this. Where is it? This. We have proved also, right? NCR plus NCR minus 1 will be N plus 1 CR. This is really important formula. It may not be much important for CBSE maybe, or maybe you can solve these type of problems. Okay, these type of problems also we have done in class. This is your example problem. And I think you can solve all the problems in your book. We have also seen circular permutation, whereas that is N minus 1 factorial ways we can arrange, right? N factorial is permutation when repetition obviously is not allowed. If repetition is allowed, it will become N to the power of the number of ways it has been. Like if there are N places, you have to arrange N ways, N objects, so it will be N to the power of N. So we have also solved these type of problems in which you have 5 places, right? 5 positions, or let's say 4 positions, and repetition of words are allowed. So 4 into 4 into 4 into 4 we did 4 to the power of 4, or 4 words are available and we have to fill 3 positions. So 4 into 3, 4 into 4 into 4, so 4 to the power of 3. So we have seen also these type of problems. Whenever it comes to digit, okay, always try to solve, always try to fill from the back side of, like backside meaning if you have 3 positions to fill and you have 10 numbers available, try to fill from here 10, 9, 8. Don't start in this order, just go in the back order. It will help you in finding the digits. Always remember that when you have to form a 3-digit number and 0 is also there. Okay, so 0, 1, 1 and 1, 0, 1 means 0, 1, 1 or 1, 1. Both are same number. Obviously, you know that, so you have to take care of those things. We have solved in the beginning of class. So with this, we are done with permutation and combination. Next chapter, you tell me which chapter you want to start. Which chapter you want to be done. And please, your homework is all questions, all exercise question. Most of the problems we have already solved it. Please solve the miscellaneous exercise. Examples also solve it. Try to solve it. Other than that, even if you are solving any other book, it's very good. And if you have doubt, you can ask me. Okay. I'm not going to give again assignments because nobody submits assignment and that really frustrates me. So I'm not going to work on that. All right. If somebody is promising that they are going to submit the assignment, and then I can make a separate assignment for them, but I'm not going to give it to everyone. Those who will submit only for them. So let Bhaskar or anyone let me know whether you want to do assignments or not, because there will be problems apart from your NCERT problems. It can come in your NCERT, your CBSE exam, but it will not be from the book. That's what I'll say. Okay. I just don't want you to solve all the problems just from books. Okay. So with this, we are done with this chapter, and let me know which chapter you want to do next. Which one? Which chapter? Yes, Srikriti?
Sequence and series, sir.
Sequence and series.
Sequence and series. Okay. So next we will start sequence and series. So in that we will study 3 types of series. One is your arithmetic series, or arithmetic progression, geometric progression. That chapter only you are saying, right? Sequence and series.
Sir.
Yeah. So what we are going to cover, let me first give you a disclaimer. First, I will first arithmetic series. Okay, geometric series, harmonic series. These are the 3 series that we are going to cover. And apart from this, one is logarithmic series and infinite series. Okay, so these are the two series that, again, I think infinite series is there in CBSE, right? And logarithmic series is again a part of it, maybe in miscellaneous chapter. I don't know if harmonic series is there or not. Okay, but anyway, we are going to see just the definition of harmonic series. Okay, because yeah, arithmetic and geometric series are definitely important, but in real life application, you will always find these three series. See, it's how ironic that is. Means you are mostly going to use harmonic series, logarithmic series, infinite series, and we pay very less attention to that, those series also. Anyway, so we are going to cover these parts. And first, obviously, I'm going to cover your CBSE, whatever is there in the CBSE book or NCERT book. Okay, so with this, we are done with permutation and combination. Thank you so much. Bye.
Thank you, sir.